Alright, there are two objectives for this glide reflection and composition lesson. First of all, students will be able to make conclusions about the order of compositions and glide reflections, whether or not the order of the two transformations matters. And then students will find the location of figures after a glide reflection. That means, like in the coordinate plane, they can identify where the image will end up. The standard from the Minnesota Math Standards is 9.3.46. Use numeric, graphic, and symbolic representations of transformations in two dimensions, such as reflections, translations, scale changes, and rotations about the origin by multiples of 90 degrees, to solve problems involving figures on a coordinate grid. So here we're using not just one translation, but two translations transformations at once. So just a couple things. I taught the same lesson last year, and in the notes that I kept, one word was written and it just said boring. Because it was just me talking at the students, and I realized there was way more potential for this lesson. They could actually discover the theorems for themselves, instead of just listening to me talk about them. And that really makes it more meaningful for the students. We use the GeoGebra app so that they can discover the theorems and make their own conclusions, and they're going to remember that much more than the one day that I told them what the theorems were. I also like this lesson because it's very collaborative. Students need to rely on their partners because they're each doing half of the construction. And so if one person doesn't finish their half, then neither of them can make conclusions. So they're depending on each other, they're working together, and I think it's really cool to see them do that.